In this example, we're asked to solve a system of 3 equations and 3 variables. The algebraic method we're going to use to solve this is elimination. Because we have 3 equations and 3 variables, we're going to have to pair up. We're going to make 2 different pairs of these equations so that when we pair them up and add them together, one of the variables is eliminated. So for example, the first equation and the third equation, if you notice the coefficient of the y here is -2. The coefficient of the y here is +2. So if we added the first and the third equations together, just as they're written, we would eliminate the y's. So I'm going to choose those 2 to pair up first. There are lots of different ways we can do each of these problems. I'm just showing one example. So I'll rewrite the first and the third. And then just as it's written, I don't even have to do anything to each equation, to either of the equations. I'm going to add down the columns. So I've got x plus -3x. So I'll get -2x. Then I'll add the y's, -2y and +2y. Those are eliminated, which was our goal. And then we've got 3z and -2z, which will give us z. And then we add our 7 and -10, and we get -3. So we've taken a pair of 2 equations that each had 3 variables and combined them together to make a new equation with just 2. Now we're going to make another pair of our original equations and eliminate the same variable. So I could either choose the first equation and pair it with the second, so then I could multiply the second equation by 2 so that this would become a 2y and the -2y, and they would be eliminated. Or I could pair the second one with the third one. So different options here. So I'm going to choose in our notes here, I'm going to pair the first one and the second one. So I've got x minus 2y plus 3z equals 7. And then 2x plus y plus z equals 4. So now I'm going to need, in order to eliminate the same variable, so I eliminated y's in this pair, I have to eliminate the y's in this pair. I'm going to have to multiply the second equation by 2. So I rewrite the whole system. I've got x minus 2y plus 3z equals 7. And now multiply the 2. So I've got 2 times 2x is 4x, 2 times y is 2y, 2 times z is 2z, and then the 2 times 4 is 8. So now when I add down the columns, I've got x and 4x, so that'll give me 5x. My y's are eliminated, the -2y and the +2y. And then I add my 3z and 2z. So I'll get 5z. And I add my 7 and 8 and get 15. So now I've taken this pair of 2 equations and 3 variables and combined them together to make one equation in only 2 variables. So now I have one equation here in an x and a z, and here's a second equation in xz. So now I'm going to solve that system of 2 equations and 2 variables. So I'm going to use elimination, since we're using the elimination method here with the 3 variables. So I've got -2x plus z equals -3, and then 5x plus 5z equals 15. So now if I want to eliminate, it looks like it would be easiest to eliminate the z's here, since there's no coefficient on the z. So if I multiply this first equation by -5, it would give me a -5z. So then when I add it to the 5z, those will be eliminated. So I'm going to multiply that first equation by -5. So that will give me -5 times -2x is 10x, -5 times z, -5z, and -5 times -3, 15. I'll rewrite my second equation, 5x plus 5z equals 15. And now when I add down the columns, 10x plus 5x, I'll get 15x. I add my -5z and +5z, those add up to 0, they're eliminated. And then I add my 15 and 15, and I get 30. So then I just divide each side by 15, and I get x equals 2. So I got my first variable. I've got to get an x, y, and a z, and I got my first one. So here's x equals 2. So now, in this system of two equations and two variables, I can now substitute this 2 back into either of these equations, and then I can get the z. So I'm going to choose the first equation because the z doesn't have a coefficient. It just has a coefficient of 1. So I'm going to use that one to isolate the z. So I've got negative 2, and I'll substitute in that 2 for the x, plus z equals negative 3. So I've got negative 4 plus z equals negative 3. And if I add that 4 over to the other side, I'll get z equals 1. So there's my second variable. So now I just can take my x and my z, and I can go back to either of the three, any of the three original equations, to get that third variable y. So I'm going to plug into the second equation here, just because the y, again, the y doesn't have a coefficient. It's a coefficient of 1, so it'd be easiest to isolate that. So I'm going to plug in, so 2 times x, 2 times 2, plus y, plus z. I'll put a 1 in for the z, will give me 4. So this will give me 2 times 2 is 4, plus 1 is 5. So I'll get 5 plus y equals 4. And then subtract 5 from both sides to give me a y value of negative 1. So my ordered triplet, instead of ordered pair with the systems of two equations and two variables, we have an ordered triplet, x, y, z, and we'll put them in alphabetical order in parentheses. So we'll have our 2, comma, negative 1, comma, 1 as our solution. Now we can always check our solution to a system by substituting our ordered triplet, in this case, back into each of the equations. So in order for this to be true, it has to satisfy all three of these. So for my check, I'll substitute into the first one, so I'll put the 2 in for the x, minus 2 times negative 1 for the y, plus 3 times 1 for the z, and see if that equals 7. So I've got my 2, and then I've got minus minus here, so that becomes plus. So this is 2 times 1 is 2, so 2 plus 2 is 4, plus 3 times 1 is 3, and that does in fact give me 7. So it works in the first one, but we've got to check all three. So now we'll substitute into the second one. So 2 times 2 is for the x, plus negative 1 for the y, plus 1 for the z, and we'll see if that equals 4. So here we've got 2 times 2 is 4, plus negative 1 is 3, plus 1 does give us 4, so we've got 4 equals 4, so that's good. And then the last one, negative 3 times 2 for the x, plus 2 times negative 1 for the y, minus 2 times 1 for the z, and we'll see if that gives us negative 10. So you got negative 3 times 2 is negative 6, plus 2 times negative 1 is negative 2. Negative 6 and negative 2 give us negative 8. Minus 2 times 1, that's minus 2, and that does in fact give us our negative 10. So it does check.